Hello, everyone. My name is Ayham I'm Senior GIS Specialist. I'm here today with Tara Twine, GIS Specialist. We work for Kathy. We are going to talk about how heat mappings can improve our understanding on site conditions and drive our decision making. As an agenda for today, we are going to briefly introduce Kathy, then Tara is going to talk about challenges and solutions that heat mapping can bring. Then I'm going to define what do we mean by heat mapping, then talk about methodology and conclude with some examples of different heat map applications. So basically, we are specialized in CBIT and BELO, and we are a global offshore geoscience and geotechnical engineering consultancy company. We provide different engineering solutions, heat mapping, one of this solution that we are going to talk about it. And I think now Tara is going to expand more on the main element of this presentation to talk about challenges and solutions. Over to you, Tara.
Thanks. So yeah, what are the challenges here? So development of offshore wind farms is a difficult process, and it's always subject to a variety of constraints. And these constraints can relate to consenting, commercial, and installation limitations. And these must be considered to understand the spatial characteristics of the site at the early stages of development. And this is crucial for minimizing risks, but also to add more certainty for installation and operation stages for the long run. So a range of data are therefore considered when assessing a site's commercial and consenting limitations, as well as the ground conditions. And collecting data is a huge task using people from various disciplines. For example, here we have a bathymetric survey, various third-party boundaries, metocean data, and shipping density. However, dealing with multiple complex data sets like these can be a difficult process and might lead to ambiguous interpretation, which risks misusing this valuable data, which in turn might prevent the parties involved from getting the ultimate insight into the spatial characteristics of their site. This misuse of data can have a strong influence on decision making, as well as installation and operational costs. So, in this context, a GIS heat map is presented as a solution. Constraints and their parameters are defined as per the development and installation method, and all those complex constraints data are fed into a model for processing. And the ultimate result, a heat map, can positively influence the process of decision making. And now Ayham is going to go into heat maps in a little more detail.
That's great. Thanks, thanks, Tara. Yeah, I think as a definition, basically, it's heat mapping as a concept is an old technique, and it's being used in GIS basically just to visualize and summarize multiple input data set using cartographic method into one singular output. And therefore, it uses classification methods to show the magnitude of feature density on a map. Therefore, it's really an effective way to reveal general patterns in data, which definitely helps us to drive better decisions. Therefore, it can be seen as a flexible method and can be applied to a range of applications in the wider industry. Generally speaking, we have two main types of heat mappings. The simple version of it that uses the traffic light system to classify the site data into visibility, whether it's visible or not visible area, or it could be more complex and more advanced version of it that assigns a specific scoring and weighting system to individual cells to rank the site by visibility. And now just let's move to talk more about the methodology of the heat map. So we've got a model in place that tackles different levels and applications of the heat map. So basically, the data element of the model is the most crucial part of it, and the data comes from two different sources. It can be open source data, or it could be site specific that comes from client survey data. And we do at this stage light data review just to make sure that we've got the essential data need to run the model. Then next step, data can be cataloged into a theme by its type, and we do here at this stage in-depth and critical data gap analysis just to make sure nothing is missed. So once we're happy with this stage, we can move to feed this catalog data into constraint register. The constraint register itself acts as a reference file that documents all the input data and where we can work out on establishing sort of scoring and weighting system to give each of the individual inputs. So for example, bathymetry can be classified by water depth, and each water depth can be given a certain scoring system. And this applies to all input data in the model. So once the constraint register is established and approved, then this can be fed into next step, which is the data processing stage. In data processing stage, we perform a different geoprocessing tasks as a model to create a heat map grid and assign scoring and weighting system to the combination of the data in order to show the overall heat map. And it's worth mentioning at this point that depending on the application of the heat map, the grid resolution varies. And if we are looking at developing a better understanding about where the area that would be most suitable for development, then a mid-range heat map grid size might be applicable in such case. But if we are doing more in-depth assessment, like foundation assessment, then higher resolution definitely will be needed. And this actually will influence the overall processing time of the data. So once the data all processed, the final stage, of course, will be data reporting. And here we looking at different type of reporting. It could be technical report and combination with drawings and figures, or it could be a GIS data package. I think this is a high level description about the general workflow. And now I'm going just to move to provide some example about different applications. So the first application here showing the boulder density assessment, where the boulders being classified into occurrence to show where the areas that would be pose some potential risk in terms of installation of the cable. Or it could be showing the risky areas based on the ground condition in combination of different data. Or it could be more complex version of it that's showing, for example, the matrix data that shows the classification of geology vs the soil type to highlight the area that must be avoided, which is the black dashed line, such example. Or it could be used for the desktop study as well to combine multiple data set and to show the overall suitability across the site, where the dashed line, black line showing hard constraint area that must be avoided for development. The other level of the heat mapping that we talked about is the more advanced level. This is an example showing heat mapping for the foundation type. So we've got 4 different foundation types, and tweaking the settings for each type shows how the heat maps itself, it changes, and that will definitely inform your decision about the site condition and which option to go with. The other example is finding the best location for OSPs or the wind turbine locations. Or it could be most advanced and more complex version of it, where we consider cost value or cost factor to be associated with each of the individual inputs, just to give you some sort of understanding about the potential cost as you go across the site when it comes to installation phase of the development. I think that's pretty much about the heat map as a concept and application, but just as a summary, just to give an idea, it's an effective way to provide better understanding, and this actually will definitely helps to make more informed data-driven decision. However, despite this importance, there are some limitations that we should acknowledge that's related to the quality of the data. That's all applications will be dependent on the quality of the data that's being used in the model and the subjectivity in applying the scoring and weighting system. And this actually should be take into consideration when it comes to reading the result, the final result of the heat maps. I think that's everything. Thank you very much.
Thank you.